Hello, and welcome again to another Blueprint London webinar. So today we're looking at tackling least privilege with Kubernetes. I'm Andy Steed, Content Director of Blueprint London, and I'm joined today by Jonathon Canada from Teleport. Hi, Jonathon. Pleasure
Hello,
to have
Andy.
you here.
Good to be here.
It's very early for Jonathon. He's over. You might have gathered from the accent. He's over in California. So I've seen he's had a good sip of coffee just now, and he's ready to take us through today's featured presentation. Just before I pass it over to him, these sessions are designed to be interactive. So please ask as many questions as you like using the question button just beneath the video here on the screen. There shouldn't be any problems with the stream, but if there is, just hit refresh and you should jump straight back into where you left us. But without further ado, I'd like to pass it over to our featured presenter today. So over to you, Jonathon.
Thanks so much, Andy. Let me just start sharing my screen, get my presentation going here. All right. So in this session, I'm going to talk about how open source Teleport can be used to create unique, short-lived kube configs, as well as best practices for applying least privilege in Kubernetes. Then this presentation is also going to be time for Q&A. Here's the agenda for today's session. So I'll start with a high-level overview of security, discussing some high-level definitions. So we have a set of definitions and concepts to work from together. I'll discuss attack surfaces, security architecture, zero trust concepts. I'll then move into speaking about using an access plane or an access gateway for accessing infrastructure. Next, I'll discuss native RBAC, role-based access control capabilities within Kubernetes itself. I'll then provide an overview of Teleport's architecture and an overview of my demo environment that I have ready, which will move me into the demo. And then lastly, I'll be sure to answer any questions that have been added to the Q&A section. So in this section, I'll define a few key security concepts, as I mentioned. The first one is going to be attack surface. As you can see here, this is according to NIST. An attack surface is the set of points on the boundary of a system element, or an environment where an attacker can try to enter, cause an effect on, or extract data from that system element or environment. So in other words, an attack surface is really describing all of the potential vectors for exploitation. It's all the different ways that an attacker could potentially get into some kind of system, some kind of data environment, etc. This slide discusses the different technology layers that you'll find within a typical organization. And as you look at each one of these layers, you'll definitely want to perform an attack surface analysis for each one. So for this first one, networks and infrastructure, some things to keep in mind, some questions to ask include how are users accessing and devices, how are users and devices accessing networks and servers, is SSH being used, how is that being secured? Applications, what are all the applications running in your network? Who has access to those, and do you have visibility on who has that access? How are all those being secured, the applications themselves, as well as the underlying operating system that they're running on? How is data being protected? And then for endpoints, so how do you control which users are actually authorized to access different parts of your network? This last bullet point, cloud, the typical are their open S3 buckets, are security groups overly permissive, are API keys being shared or not rotated? And of course, with all of that, making sure that there's logging, there's auditing that will help you to get insight into everything that's happening within your organization across all these different layers. And of course, when we're talking about Kubernetes deployment, that can cover all these different layers. Kubernetes, it's running on hosts. There's an operating system underneath. There's applications in your Kubernetes clusters. There's databases involved. It might be deployed in the cloud as well. So a lot of things to think about when you start deploying Kubernetes. The last high-level security concept I'll mention here is zero trust. Now, zero trust is a model that was developed in response to NIST's request for feedback to a document that's called Developing a Framework to Improve Critical Infrastructure Cybersecurity. So nice long title for that document. But according to the analysts at Forrester, there are three main concepts of zero trust. You can see these 3 bullet points here. First one being ensure all resources are accessed securely, regardless of location, adopt a least privilege strategy, and strictly enforce access control, and then inspect and log all traffic. Now, how Teleport can help with all 3 of these bullet points is Teleport uses end-to-end mutual TLS encryption. Open source Teleport allows you to map GitHub teams to groups and users that exist within your Kubernetes clusters. And then for inspecting and logging all traffic, Teleport actually logs every kubectl request, ties it to the identity of the user who is making that Kubernetes request, so that actual kubectl command. And every kubectl exec session gets recorded by Teleport in a kind of video playback. So if somebody goes into a pod, you have a full video recording of everything that happened in that exec session into that pod. So next I'll discuss using an access plane. And as I mentioned earlier, when you're talking about Kubernetes, odds are is that you're end up with multiple clusters and just a lot of things under the hood of where those Kubernetes clusters are located and what they have running in them. And with these multiple clusters, you might have development cluster, staging, production cluster, etc., or multiple Kubernetes clusters per region or per cloud environment. But in order to deal with all of those, you really want to centralize the access. So you want to kind of pipe all of your developer access to your clusters through a single gateway so that you can enforce all of your policies on that gateway. And that gateway that you have is also a great place to attach to your single sign-on identities any requests and modifications that they are making. So that way you get accountability and user attribution from everyone in your organization about who does what and when to your production and staging environments or whatever environments you might have internally. And you really want to make sure that the gateway only allows authenticated SSO users through and records their identity with their requests. So if somebody were to say, SSH as a root user, you want to have it tied to the actual identity, so the actual person who is SSHing as root. Or if somebody is doing critical kubectl commands, you really want to see the specific user who is making those critical kubectl, those Kubernetes API requests. And the other thing is, even though you're using Kubernetes and it does kind of hide a lot of the underlying hardware and infrastructure, it's important to remember that that's all still there. So there's still servers, the applications in your clusters, there's operating systems that need to be patched, and most likely you still manage everything under Kubernetes via SSH, so SSHing into those worker nodes that you have, or some similar access. So you definitely don't want to forget about all those other aspects. To really do all the same enforcement that you do for Kubernetes, to attach SSO identities to all of your access control. Don't forget about SSH, databases, internal applications that you have running. And when you are using SSO identities, you really should map the users and groups in your identity provider, so the roles of your users within your organization, to users or groups that you create within your Kubernetes clusters. And groups and users in Kubernetes, those can be created using native Kubernetes role-based access control, which is what I'll get into in the next few slides. So this is where we get into how to enforce least privileged access by implementing role-based access control. So role-based access control, or RBAC, is a method of regulating access to computer or network resources based on the roles of individual users within your organization. This slide discusses roles versus cluster roles in Kubernetes. And as you can see here, for a role, so a role always sets permissions within a particular namespace. So when you create a role, you have to specify the actual namespace that that role belongs in. A cluster role, on the other hand, is a non-namespace resource. And the resources, they have different names, role and cluster role. It's because a Kubernetes object always has to be either namespaced or not namespaced. It can't be both. And if you want to define a role within a namespace, use a role. If you want to define some role cluster-wide, use a cluster role. And in my demo, I'll demonstrate using a Kubernetes role to limit a Kubernetes group to a single namespace rather than using a cluster role. And I'll show that part of my demo. That brings me to an overview of my demo environment and just the teleport architecture. So when I'm talking about a teleport cluster, that really consists of everything that's within this box here. That's going to be teleport proxy, teleport auth server, which acts as a certificate authority, and where all of the detailed audit logs are stored by default. There are HA, highly available options available, and we'll get into in this presentation, but something to keep in mind. And then the last part, of course, of a teleport cluster are the compute resources that you'd be accessing within your organization. So SSH servers, Windows desktops or servers, Kubernetes clusters, databases, as well as internal applications. That also includes access to the AWS console and AWS CLI. Now, the component that users are always going to be interacting with is this teleport proxy. So you can think of this as like that access gateway I was describing before. So this is where all of the policies are getting enforced as users go through this proxy in order to access some compute resource. Now, how a user authenticates with Teleport is just using the same SSO that they use within their organization. And based on their role within the organization, that is going to determine what they are authorized to access within these compute resources that are part of this Teleport cluster. So if somebody is a role of maybe admin within your organization, they might have admin access to all their resources. If somebody's a developer, like this person here, they might only be able to access infrastructure that's within a development environment, as an example. And so how a user will start their day in order to get credentials that they can use to start interacting with these compute resources is first, as I mentioned, they will log in via SSO. Upon successful authentication, they will then receive short-lived certificates. The time to live on those certificates is completely configurable, and it is based on individual roles. So for maybe a production role, you could limit that to maybe just a few hours, whereas something in the development environment, maybe 12 hours is what you would set for those certificates. And the two main ways that a user will interact with the teleport cluster in order to get these certificates is either using TSH, which is teleport CLI client, so in a terminal window is one method. The other method is there is a UI, a web UI served from this teleport proxy. So in a web browser, users can also log in and access compute resources through a web browser through this proxy. Now for the case of Kubernetes, each user will actually receive a short-lived kubeconfig when they log in. So there's no more need to share long-lived kubeconfigs where everybody has system masters, admin access to every Kubernetes cluster. With Teleport, you can be very granular in terms of what clusters somebody can access, and labels is how we do that. So label-based access controls, as well as how long those kube configs will actually be valid for the individual user. And because the user is getting issued a kube config, and if there's an existing kube config for that user, this entry just gets appended, so it's not going to blow anything away. But because the user is getting a short-lived kube config, every action that they do, it's going to be tied to their actual identity as it is within SSO. If somebody does kubectl get pods, you'll see the identity of who's actually issuing that kubectl get pods command. The last part of this slide here is these access requests. What that is, it's just-in-time access or a way to temporarily elevate permissions. So let's say this developer temporarily needs access to a production Kubernetes cluster. This developer could request a more privileged role that would allow them to access that production Kubernetes cluster. And that request could go to one of these third-party applications. You can also use our APIs to create any other custom integration. These are just the ones that we've built out ourselves already. But wherever this request for that more privileged role arrives into, one or more users could approve or deny that request. If approved, this user is able to assume that more privileged role, and they will receive updated certificates that reflect what is authorized in that new, more privileged role. And they will be able to use those certificates to access whatever is authorized in that role they've assumed until the certificate expires, at which time they'll automatically revert back to their base level of access. So in my demo environment, I'm going to pretty much switch between two different users, one who's an admin, one who's a contractor, so I can show you how it looks for users with different roles. And I can also show you how that contractor could go about requesting a more privileged role to do something that by default they're not able to do. So let me switch over to my demo environment at this time. So as I mentioned, that teleport proxy, the component that users will always be going through, there is a web UI served from it. So this URL that I have, this is a teleport proxy that I have in my own environment. You can also access all your compute resources in a terminal window. So TSH is Teleport's CLI client. So I can show you what happens when I log in and I reference the same proxy that I'm using back here in my web browser. So if I hit enter, I have a message of the day configured. I hit enter again, and it kicks off my SSO sign-in. I'll choose my teleport account here, which is I have an admin role here at teleport. So successfully authenticate. If I return back to my terminal window, I have information about my session, any Kubernetes groups that I'm a part of, users I'm allowed to SSH as, and how long my access is good for. I've set it's about 12 hours for myself. From here, if I wanted to start viewing compute resources available to me, I can use TSH for that. I want to look at the applications or AWS CLI, Kubernetes, all kinds of stuff. If I want to view servers available to me, do TSH ls, and I could SSH into these using either node name, IP address, or even labels as my target for SSH. But for now, I'll just stick to Kubernetes. So it'll list the Kubernetes clusters available to me here. TSH kubels shows me these two different clusters. I currently logged into this one. And because Teleport has appended a short-lived kubeconfig entry to my kubeconfig, I can now just use regular kubectl. I'll just do kubectl get pods. And every request that I'm doing here is getting captured in Teleport's audit logs. And also, if I exec into one of these pods, everything I do in this exec section is also going to be captured. We go in a bash shell into this pod. So these Kubernetes. Exit from that, and what I'll do, I'll go back into my Chrome browser so you can look at the audit log and see what was captured. And you can see that there's multiple, you can set up multiple SSO integrations with Teleport. Open source, GitHub is supported. That involves mapping GitHub teams to roles that you create in Teleport. For this, I'll just log in via Auth0 and select my Teleport account again so that I can show you the audit logs because I have an admin role with this. And so when I arrive, similar to the CLI in here, I could click through to see my SSH servers, my applications, including accessing the AWS console, the Kubernetes clusters, databases, Windows desktops or servers. But I will go into the audit log, and in here you can see that every action, so starting with my SSO login that I just did before, it's tied to the actual identity of who is doing each one of those actions. So if I want to look at Kubernetes requests I was making, it's stored in this JSON formatted log. It's very easy to send to some kind of Splunk, Elk, a SIM that might be used. And Teleport does have a FluentD plugin that can be used to easily send these logs pretty much anywhere that's needed. FluentD is an open source event forwarder. But in this case, this was my get pods that you saw me do just a moment ago, what namespace it was in, and most importantly, the identity of the user who is actually making those requests. And that's important if you're trying to do some root cause analysis, so figure out where compromise might have occurred, maybe trying to develop a timeline of events. In Teleport, you're going to see the identity, so it can really help you to pin down potentially compromised account if that were to happen. Also, if you're going through an audit, the ISO, SOC 2, whatever it is, pretty much all those compliance frameworks have pretty serious requirements around login, identity, access management, and Teleport can check the box on all of those. The last part is the actual recording of what I did when I execed into a pod. So again, share this with an auditor, or even for training purposes, if you were to record some task that you do, share it with a new employee, and now they can watch and see what you did. And to make it easier too, they can even copy commands that they're seeing, paste them to their own environment. So that's as an admin user. What I can do now is show what it's like for somebody who has, by default, just no permissions. I'm going to do that in my Firefox browser here. And so if I log in, this is the same proxy that I've been interacting with in the CLI and in my Chrome browser, except this time I'm going to choose my personal Gmail account. And the role of this personal Gmail account is contractor. And you'll see, even though it's the same proxy, there's nothing here from my perspective. So I've really limited what this person is able to do and see. They can't look at any logs. The only thing I'm allowing them to do is request access to this one specific role. So I'm going to ask for access please, send that off. I do have an integration with Slack set up. So that request just arrived into this Slack channel that I have. I can see which teleport cluster this is for, who's requesting it, the role they want, their reason. And if I click this link, it takes me back into my Chrome browser where I'm my admin user, and I'm somebody who is going to be able to approve or deny this. So I'll approve their request. Go ahead, submit that. I look here in Slack again, it's approved with the reason. I do have a timestamp of that happening, who approved it. Of course, teleport is also capturing all of that in the audit logs as well. Access requests are created, reviewed, and then the JSON logs go along with it. But if I now go back into Firefox as my personal Gmail user, the status of this request has been pending, but because I just approved it, I'll refresh the page. It's now approved. So I'm going to assume this dev role now. And anybody with the dev role, I'm saying that they can only use it for about an hour. And now if I go to look at my servers or applications, anything else, there's now stuff that I can actually see and interact with. And it still is a subset of what my admin user is able to see. So here back in Chrome is the admin. You can see in this example, there's 5 servers, but for this user, there's only 2 servers. And it's because Teleport uses labels as part of role-based access control. So what I've said with anybody with this dev role, the only label that they're allowed to interact with is infrastructure that has this label, environment equals development. So they're not even going to be able to see or interact with anything else that's out there. But let me switch back to the CLI so I can show you that contractor user trying to interact with Kubernetes resources. So let me log out as my admin user, TSH log out, and I will do a TSH login again, same proxy. I'm going to say browser none. What this option is doing is it's going to suppress automatically opening a browser tab because I don't want it to open in my Chrome browser where I'm logged in as my admin user. I'm going to take the link that it gives me and paste it into my Firefox browser where I am that contractor user. Paste that in here. Choose my personal Gmail account, contractor user. Successful login. I return to my terminal window. And here I've logged in. I have that contractor role. But something that I can do here is I can, because I have a role request that was already requested, like you saw me do in Firefox and approved in Chrome by the admin user, I can see if it's still there. So that's the one that's still there. It was approved. So I can just go ahead and assume that. So if I sh login, request ID, take that request ID. Again, this is my previously approved role request that you saw me do in the web browser. So now I've assumed that dev role about an hour, as I mentioned before. And so now if I do TSH kubels, this Kubernetes cluster is available to me. I'm going to select one. I'm going to log into the first Kubernetes cluster that I have. Now what I've set up for this contractor, because I'm very paranoid they're a contractor, is I've enabled per session MFA. So even though they may have gone through authenticated via SSO, which might have MFA as part of that authentication process, so they now have certificates locally, but to now use those certificates, I can force them to use a YubiKey authenticator app or something that uses WebAuth. So if I try to do kubectl request here, something else too is that I have limited somebody with the dev role to only be able to access resources in the dev namespace. So if I try to do this kubectl get pods in the default name, it's going to fail. To demonstrate that, I'll hit enter. I'm going to tap my YubiKey. Make sure it's plugged in. In here. So possibly running into the try unplugging, plug. It's lighting up now. Should be good with my YubiKey. Now. So I think something is happening with my YubiKey here, but what should happen is after tapping my YubiKey, my kubectl request would go through. But as I mentioned, because I've limited somebody with the dev role to only be able to interact with resources in the dev namespace, this kubectl get pods command would fail. But if I were to get pods in the dev namespace, that would go through successfully. So the point of this is that you can use these teleport roles to map groups or users that exist within your Kubernetes clusters to identities that you have within your identity provider. So the most common way of doing that is mapping groups that exist in your IDP to the groups that you create within your Kubernetes clusters. So with that, let me return back to my slides to summarize what was covered there. So to summarize, remember that Kubernetes expands the attack surface of your environment. But if you're introducing a new layer, you have to make other layers less relevant. And what I mean by introducing a new layer, adding Kubernetes, which underneath Kubernetes, operating systems, applications, databases, and a lot of potential vectors for exploitation with an entire Kubernetes stack. So something to consider turning off SSH for the majority of your engineering team. Having both Kubernetes and SSH present can increase the probability of you getting compromised. If you do have SSH access enabled in your Kubernetes clusters, just be sure to apply role-based access control and synchronize the two so that those users who have SSH access and Kubernetes access, that they have the same authentication gateway, the same access gateway to go through as they go to SSH into something, or as they go to access a Kubernetes cluster. Then, access to all of your different environments, dev, prod, etc., really should all be controlled through that same gateway for access and for authentication. Role-based access control tied to your SSO identities should also be used. So that way, every single request that a user makes, it's going to be tied to the identity of who is actually making that particular request. Last part, of course, is make sure there's logging, auditing happening, and that you're regularly inspecting and auditing all the access. It's great to be gathering logs, but make sure you have a system in place so that you can have alerts generated. You're looking at those logs, so you actually have eyes on. So if something were to happen, you can quickly respond to it. For next steps, there's a few links here I recommend checking out. I highly recommend watching this session. This is best practices for auditing Kubernetes. You'll learn about auditing, logging, alerting within a Kubernetes cluster. As of course, we're open source, so please check us out on GitHub. You can start playing around with Teleport today. And we're hiring for every role, growing like crazy. So please, reach out, check out what our openings are. With that concludes my presentation. I can hand it back over for some Q&A.
Hey, Jonathan, how are you?
Good.
Thank you very much for that. That was great. I got a couple of questions. Good to finish this sort of thing up there with a bit of a chat and go through some of the stuff. What your first point was about vulnerabilities, attack surface. So, where do you see the most vulnerabilities for that attack surface, and how often are they? I mean, is it a big problem or a bigger issue?
Yeah. So it's a very big issue. Is what I see most organizations doing is, the Kubernetes API server will just be completely public, and everybody just has the same exact kube config, and they all have the same access to every Kubernetes cluster. So they're sharing overly permissive kube configs that do not expire, and they just have a publicly exposed Kubernetes server API. So if there's any vulnerability in that, in a particular Kubernetes release, anybody can just start hitting it. That was one of the issues with the Colonial pipeline that happened in the United States. May of last year, I think. Attackers were able to exploit some Kubernetes clusters, and that essentially shut down one of the most important oil pipelines in North America.
Right. So so a big issue there.
Yeah.
So I'm gonna switch now to sort of first steps and starting to use Teleport and that kind of line of questioning, because I imagine a lot of the people who are watching this are thinking about this kind of solution. So what's the kind of first benefits people feel when they start using Teleport or a tool like Teleport? Where's the real early payoffs, early wins?
Simplicity of access to compute resources. Because what happens is a user gets onboarded in SSO. Based on their group membership in the SSO, they immediately have access to start accessing their resources. So no more having to provision SSH keys, put public keys in random places, creating user accounts, Kubernetes clusters. It's really, you get onboarded into SSO, now you have access to do your job. You leave the organization, you're removed from SSO, your access is revoked. You don't have to try to hunt down where those public keys are. If there's a shared private key out there, it's all certificate based. So the certificates expire. And you can use per session MFA as well. So let's say in the event your laptop was stolen and you happen to have valid certificates on there still, if you're using per session MFA, they're not going to be able to use those certificates without a YubiKey authenticator app or something that uses WebAuth.
Okay.
So ease of access.
Yes. Yeah. And is there any sectors, any use cases that are particularly prevalent for you guys? I mean, do you tend to get more users in, I don't know, finance or etc., or is it pretty much across the board?
Yeah, it is across the board, but definitely companies with strict compliance frameworks like reach out to us quite a bit. In the United States, the 6 largest tech IPOs of 2020 and 2021, they all use Teleport as part of their path to IPO, just because the audit capabilities of Teleport, the ability to enforce role-based access control across all compute resources, it makes all that easier for any compliance, any audits that they're having to do as part of IPO, or just part of ISO, SOC 2, whatever it is.
Yeah, perfect. So a very compelling reason to use it again. But speaking on behalf of the people who are watching now, so they're wanting to give it a try, and they'd like some more resources, that kind of thing, trials, stuff like that. Is that all available? Is there any more resources? Obviously, this will be available on demand straight away afterwards, so you can pause and rewind any of the complicated demo bits if you want to go over those. But is there some resources that Teleport has and access to trials and stuff on your website?
Yeah, absolutely. Yeah, on our website, of course, there's links to both the open source product as well as there's an enterprise edition. That through that, it'll have you reach out to the salesperson, reach out to you for a trial license for the enterprise version. But also, you can just go to our GitHub repository and you can just, if you want to build Teleport from source, you can do that too.
Cool. And GitHub links and stuff on the website, are they? And things like that.
They are, yeah. Mm-hmm.
Yeah. Oh, excellent. Well, there's nothing stopping. It's nothing stopping you then for the people who are watching. Yeah, I think that about wraps it up though. I'll let Jonathon get back to his coffee. Thank you so much for joining us. We do appreciate it's early for you. I hope everybody at home's enjoyed the session. I certainly did. So with that, I think we're going to wrap things up. And I say thank you again and goodbye to Jonathon. And thank you for everybody at home for listening. So
thank you, Andy. Thanks everybody for attending.
Thanks, Jonathon. Thanks. Bye-bye.